I was recently asked by a high school student about this problem. It's a little nice problem which can be solved without doing much calculations. The problem asks that if we have a quadratic equation ax square plus bx plus c is equal to 0, which has no real roots, the coefficients a, b, and c are real numbers with a not equal to 0, and satisfies the condition a plus c is less than b. What can we then say about the sign of the expression 4a plus c minus 2b? That means, is 4a plus c minus 2b greater than 0, or is it less than 0, or equal to 0, or nothing can be said? It might happen that for some values of a, b, and c it is positive, whereas for some other values of a, b, and c it is negative. So we have to determine which of these four conditions we are in. That is it always positive, or is it always negative, or is it always equal to 0, or is it that we cannot say anything? So it depends on the values that we choose for a, b, and c. Now, to proceed with this, we will look at some simple facts. So let's begin with understanding about the quadratic expression ax square plus bx plus c. If we look at the graph of this quadratic expression, we will see that the graph depends on the sign of a. If the a is positive, then it would be an upward opening parabola, as can be seen from the black and this red curves. And if it does not have any real root, then it would be the black curve. That is, fx would be greater than 0 for all x belonging to R. If there are real roots, then it would be like the red curve, and in some zones it would be positive, and in some other zones it would be negative. Say, for example, if we have these roots as alpha and beta, if we are looking at x which is less than alpha or greater than beta, then fx would be greater than 0. Whereas if you have x which is between alpha and beta, then fx would be less than 0. If a is less than 0, then the curves can be of this kind, of yellow or the green. Again, the yellow curve takes both kinds of signs. So fx here is less than 0, and here it is greater than 0. So, and again here it is less than 0. So for this yellow curve, we see that fx takes both positive and negative sign. And for the green curve, which doesn't have any real roots, we see that fx is less than 0 for all x belonging to R. So fx is always negative for this green curve, which does not have any real roots, and a is less than 0. We keep this in mind as we proceed. Now, towards solving this problem, we evaluate fx at the point x is equal to 0, and what we get is the value c. Now, from what we just saw, if a is greater than 0, then c has to be greater than 0. So this is the point c here. So this point is c. So c has to be greater than 0. If a is less than 0, then this point is c, and then c is less than 0. So that is what we have first noticed here. After that, we notice the value of f minus 1. Now, f minus 1 is nothing but a plus c minus b. And we have been told about this. So we have been told that a plus c is less than b. So f of minus 1 is less than 0. So f of minus 1 is less than 0 as a plus c minus b is less than 0. Now from that immediately we can conclude that's because there is f has no real roots that fx is less than 0 for all x belonging to R. So since f has no real roots, fx is less than 0 for all x belonging to R. So this has to be then the green curve. So this has to be then the green curve, which is that fx is less than 0 for all x. Now we evaluate f of minus 2. Now f of minus 2 gives us 4a minus 2b plus c. And since we are working with the green curve, we know that fx is less than 0 for all x belonging to R. So f of minus 2 has to be less than 0. So therefore, 4a minus 2b plus c has to be less than 0. So this concludes the solution to the problem. We can conclude that for all choices of a, b, c, satisfying the condition that a is not equal to 0 and a plus c is less than b, we would always have 4a minus 2b plus c to be negative. Thank you for listening.